Hello, Assalamualaikum. Today we are going to present about analysis of vanillin in white chocolate by gas chromatography. For introduction, gas chromatography is a technique for separating components based on their volatilities. The components of a vaporized sample are separated as a result of being partitioned between a mobile gaseous phase and a liquid, or a solid stationary phase held in the column. Vanillin is an organic chemical that, also known as one of the most common food flavoring ingredients, could serve as a potent antioxidant. It's a phenolic aldehyde having aldehyde, hydroxyl, and ether functional groups. Vanillin is generated both naturally and synthetically. Flavors, food, fragrance, and medications all included. Vanilla flavors is found in the majority of chocolate components, and vanilla utilizes vanillin. Chocolate is made from cocoa, while white chocolate is made by combining processed cocoa chocolate while milk powder to make it white. In gas chromatography principle, the sample solution injected into the instrument enters a gas stream which transports the sample into a separation tube known as the column. The various components are separated inside the column, such as vanillin in fruit and essential oils. After they pass through the column, they are separated and detected electronically by detector. A method for determination of vanillin by gas chromatography, vanillin were extracted through fused silica wall coated in capillary column because they are high resolutions, high sensitivity, and have short analysis time, while the injection mode that was used are split mode because they produce narrow and sharp peaks. Detectors that was used are thermal conductivity detector, or TCD, because they can be used in any sample compounds and responds to both organic and inorganic.
Methodology: sample preparation. Vanillin in sample were extracted with SPME through a fused silica fiber coat with divinyl benzene or polydimethyl siloxane. The analytes were dissolved by GC at 260 degrees Celsius for 7 minutes and separated on dB5 ms capillary column and detected by ms with EL source by selected ion monitoring mode. As a result, the limit of detection of vanillin and ethyl vanillin was 0.1 and 0.05 mg or kilogram. The spike recovery was between 90.0 and 100%, and the RST ranged from 1.9 to 5.1%. This method eliminates the interferences from complicated metric effectively. Furthermore, the relationship between odorants and sensory perception of chocolate was measured by quantitative analysis, sensory evaluation, and correlation analysis. This method eliminates the interferences from complicated metric effectively. The method was successfully applied for quick determination of vanillin and ethyl vanillin content in milk powder samples. Sample analysis. Honestly, there is no such thing as white chocolate. The white chocolate that we see on the market is a combination of processed chocolates from cocoa added with milk powder to make it white. In addition, some chemicals were added to the original dark oak milk chocolate to validate their roles in the aroma property of chocolate.
From the figure 1, we can know the detection time of the compound by looking at the P. In this table, we list the compound detection time and detail of the compound that we have found in this analysis.
For the next data analysis from 23P, there are a lot of polar compounds by the end of the experiment, where most of these crystals listed with the fatty, fruity, and floral aroma inside the vanilla.
Chromatography (GC) was used in this experiment because it's only capable of analyzing volatile and semi-volatile compounds, ranging in molecular weight from helium hydrogen to roughly 1250. The flame ionism detector (FID) is a good choice for this investigation since it detects hydrocarbon but not pH carbon containing substance. The temperature is the quantitative analysis for analyzing the sample in gas chromatography in this experiment. The graph plot from this chromatography reading demonstrates that temperature increase proportionally as the number of retention time increase. The size and area of the component P are proportional to the amount of the component reaching the detector in quantitative analysis. White chocolate contain vanillin, ferroalkyl, ferroic acid, caffeic acid, p-coumarin, and triacid. The other volatile were detected at concentration of 1 less than 10 ppm and in the 3,4 extract, representing less than 1% of the total abundance. The volatile profile of the white chocolate is compound of one chemical class, aldehyde, that is 3. Table 1 shows the chemical composition of the white chocolate extract in detail. Based on area abundance, the compounds are present in ascending order by chemical grouping. Figure 1 also shows that when the quantity increases, the wavelength also increases. White chocolate sample is contained of total of 14 fatty acid and 6 saturated fatty acid. The most abundant chemical in this white chocolate sample were hydrocarbons. This was shown in the table 1.
By using gas chromatography osmosis analysis, new compounds are identified as aroma impact compound in vanilla, which are 3-hexanyl diisopropyl disulfide, double E2,4-nonadienal, 2-E-inosanyl, and phenethanol, acetopyrrole, transguanyl cetone, and 5-vinyl guaisol. The primary purpose of this gas chromatography osmosis analysis is to distinguish objective compound from the volatiles with the other impact. However, it will have been extremely difficult and time-consuming to try and identify each one of these 198 combined events. From this analysis, we found there are 35 of 45 aroma impact compounds were positively identified, while 4 were tentatively identified and 6 remain unknown. Since the most of the unknown compounds were part of the background, it was not considered a priority to investigate their identities. Therefore, aroma impact compounds were identified based on retention index, aroma quality perceived at the sniff spot, and mass spectra, or by retention index, aroma qualities, and injection of authentic compounds. The different overall aroma between vanilla of different species are attributed to the various composition of aroma impact compounds. The aroma of vanilla appear to involve a higher number of impacting odorants compared with the 100 total result of gas chromatography osmosis analysis of the other 2 commercial species. From gas chromatography analysis, the 26 odorants have been reported in vanilla planifolia extracted, while 38 odor active components of vanilla tahitensis extracted. The most abundant compounds, according to the gas chromatography mass analysis, are vanillin and anilyl alcohol, which are not categorized as primary aroma impact compound in gas chromatography osmosis analysis. This is explained by diluting effect caused by the illusion white peaks that produce long-lasting strong sweet note that difficult to pinpoint at given detection times.
In the conclusion, difference in volatile composition and descriptive taste properties between dark chocolate and milk were observed. Then, the relationship between aroma-active compounds and sensory perception in chocolate has been confirmed. Next, this method has been successfully used for rapid determination of vanillin white chocolate samples. Among the limitations of the current study is vanilla dosage in white chocolate and milk were set experimentally. This being the case, Future studies should investigate how change in vanilla concentration in chocolate affect taste perception. Second, with a limited number of participating users in 4 countries, only indicative sensory choice can be inferred. This is recommended to increase the sample size in the future research. Finally, sensory and non-sensory research methods should be better linked through applications of similar sensory descriptors. For the factors affecting GC separations, first, volatility of compound. Low boiling point components will move faster through the column than the high boiling point components. Next, column temperature. Raising the column temperature speeds up all the compounds in a mixture. Next, column length. The longer the column, the longer the elation time, and sometimes used for better separation. Next, polarity of compounds. Polar compounds will move more slowly, especially if the column is polar. Next, flow rate of the gas through the column. Speeding up the carrier gas flow increase the speed of all compounds moving the column. Finally, column material adapted to the isolated compounds.